Okay, so we're going to look at this graph. I'll show it to you in just a second. I just want to write down what the exercise actually is. So exercise 1, so we're going to use the graph to figure out the left limit, right limit, and two-sided limit, and function value at each value, blah, 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 blah. Okay, so use graph to fill in the table. So basically, at each of the interesting x values, I want the left limit, the right limit, the two-sided limit, and the function value. Okay, so this is going to be our graph that we're working with. And then our table, I'll write out the table down here. Right, so here's the value of a. What is the left limit? What is the right limit? The two-sided limit. Then what actually is the value of the function? And we're going to look at x equals 1, x equals, or a equals 1, 2, 3, and 4. Okay. So this is meant to be kind of quick. So let's look at x equals 1. So at a equals 1, I want to know what is the left limit, the right limit, and the overall limit, and the function value. So what do we think? So for the left limit, what do we think? Or you can actually just give the whole line, right? So for a equals 1, what would you give for that whole line? Just put it in order. The left limit, the right limit, the two-sided limit, and the function value. And so keep in mind that we're looking at as x approaches 1. So we're looking at this area of the graph as x approaches 1. What do you think? What about the left limit? Maybe it looks like a lot of people are maybe a little stumped, maybe just still copying the graph. What do you think about the left limit? Okay, Edgar. So positive infinity, Sarah, positive infinity, just get positive infinity. Okay, good. Right? Why is this limit positive infinity? Again, let's think about how we use graphs, right? We think about it this way. We trace the numbers towards x equals 1 on the left side. What happens to the corresponding y values? We can see that all of those y values are getting bigger and bigger, and they are getting arbitrarily large, or at least the graph suggests that, right? The graph suggests that as I get closer to 1 on the x-axis, all these numbers, all the y values will just kind of shoot up as much as I want, right? That's what's suggested. So the graph very strongly suggests that as x approaches 1 from the left, I get positive infinity. All right, so using that as kind of your base, what's the rest of this chart, or what's the rest of this row here? You can just type INF for infinity, inf for infinity. Good, so then from the right, it also goes up to infinity, right? We can see it goes up to infinity. X approaching A, I see people writing D and E, right? Because from the left, or do we say D and E actually? You guys are right. You're actually saying D and E for the function value, sorry. You guys are also saying plus infinity for the two-sided limit, which is correct, right? On both sides, we go to the same infinity. So therefore, overall, it's infinity. And then the actual function value is D and E. So yeah, I was misreading what people were running. So all of you actually had it right. I was just misreading it. Okay, so let's quickly now do x equals 2. So as a approaches 2, what happens? Let's type out the whole row of 4. So now we're looking at x equals 2. Let's see. We see, it looks like everyone is more or less saying the same thing, it looks like. Right, on the left side, it goes up to plus infinity. On the left side, it goes down to negative infinity. So then overall, since the two infinities don't match, the overall limit does not exist. And the function value also does not exist. Good. Now x equals 3. Let's see. So I think, has it. So from the left, we get to 5. On the right, we have plus infinity. Good. Overall, right, the left and right don't match, so therefore it doesn't exist for the overall. And the function value is 5. Caleb says, I don't know about you guys, but I find graphs much easier because I can visualize it. Yeah, I like graphs too, right? Because we think about it analytically and graphically, right? We have multiple ways of kind of looking at it, right? That's why I always kind of like to go back to graphs. Even if graphs, aren't proofs of things, they really do help us kind of build intuition. So that's why I always like going back to them. All right, now what about x equals 4? So we get from the left, again, we see 5, right? That open hole at 5. On the right side, we see negative infinity. Good, everyone's saying that. The left and right don't match up, so we get does not exist. And there is no function value there, so it does not exist. So very good. So everyone in chat doing very well. Okay, so you may have not ever seen examples like this where there actually is a function value or some sort of hole on one side. You might be used to vertical asymptotes where it goes to infinity on both sides or opposite infinities. Why is it 5 and not negative infinity? Well, let's look at x equals 3. Why is the left limit at x equals 3 equal to 5? So remember what we do. If I'm approaching x equals 3 from the left, that means anything that is on the right, I don't care about, right? At x equals 3, I don't care about, and anything on the right, I don't care about. So block all of this from your mind. None of that is relevant. So when I look at x equals 3, if I trace as x goes to 3 from the left side, what happens to all the y values? All the y values approach the y coordinate of that pink point, which is 5. They don't approach negative infinity. All right. What is happening on the right side is completely irrelevant. Okay, good. Now I just have kind of one bonus question before we move on to more examples. So I'll zoom in. So how many vertical asymptotes do you think a function can have? Infinitely many? Can you give me an example? Now you can just draw it, sure, but can you give me an example of an analytical function? Good, tangent of x. Yeah, cotangent of x also. So this is an example of a function with infinitely many vertical asymptotes. Right, every odd multiple of pi over 2 is another vertical asymptote. Right, and the function looks something like that, right? Okay, so I just want to kind of point that out. So a function can have as many vertical asymptotes as you like. In fact, it can even have infinitely many.